Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Luqman bin Rosli. My number matric is AA 9191663. Okay, now for the presentation of our final year project. Okay, for the first thing, for the introduction, what is thermoelectric cooler box? Okay, the first one, it is used to cooling the stuff like beverage using the Peltier model and not using the compressor base like a normal and conventional refrigerator. Okay, for the explanation for how the Peltier module will work. Okay, when Peltier module connected to the power source, it will generate the thermal energy cold and hot at different side of the module. One side will produce a hot side and another one will produce a cold side, which we will be use the cool side to cool our beverage in the cooler box. Okay, the cool side will get the maximum of cooling when heat at the hot side release to the maximum. Okay, for the objective of our final year project, the first one, we have two objectives. For the first one, designing an electrical cooler system device prototype that use the Peltier module instead of the compressor based cooling system as for the conventional refrigerator. Okay, for the second one, testing the functionality of our design thermoelectric cooler. Okay, now we move on to the implementation of the project. Okay, as the figure show, hardware implementation for our project is the first one, the power supply. We use AC/DC 12 volt because the power that the power supply give to the cooler have the optimum power to generate the to generate and supply to all the component in the cooler. Okay, the second one is Peltier module. Okay, this is the main component in this project. This is the component that will produce cool side, which we will use and benefit it to become the main source of cooling in the cooler. Okay, for the next one, the heat sink. The heat sink will catch all the heat and the hot side of the Peltier, so that our component will not melt or will burn. Okay, for the fourth one, the CPU fan. This component also will prevent any overheat or burn in the component, so that the component will work properly. Okay, for the software implementation, which is we use the Onshape computer aided drawing because it is easy for us to use Onshape because the Onshape is a online website that we can save it on cloud, so that doesn't require us to store it in our local storage in computer. Secondly, all of the group member can access to the file and the document of the drawing, so that we can discuss and talk about the design and also repair and improve the design and the drawing details. Okay, I think that's all for me. Now I will deliver my presentation and pass my presentation to my next groupmate.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azrul Arif binti Aziz. My metric number is AA 190955. Okay, so I will explain about the assembly process. So for the first, we prepare the main component like a power supply, CPU fan, heatsink and the Peltier module. Okay, so next is we place the Peltier module at the big heatsink. We hot side touch the heatsink. Okay, so for this is this gray color is the thermal paste. Okay, the main role of thermal paste is to eliminate air gap or space, which act as thermal insulation in order to maximize heat transfer. So we apply the thermal paste at the both sides. Okay, next is we place the small heatsink at the cool side of the Peltier, okay, like this, and we tighten the bolt and the nut. Okay, for the next is we install the CPU fan at the both heatsink following the size. In this big CPU fan installed at the big heatsink, and the small CPU fan installed at the small heatsink. Okay, next we repeat the process 2 until 4 to make the another one of cooling element. Okay, so as we use 2 Peltier, so we must make the 2 cooling element like this. Okay, the next is connect all the component wire, and that is Peltier and CPU fan together to get a single terminal negative and positive. Okay. Next, we connect all wiring to the power supply. Okay, this red wire is the positive wire, positive terminal, and the black one is the negative terminal. Okay, so these 3 wire is connect to the plug and the power source. Okay, this is the earth, neutral, and live. Okay, next we cut the polystyrene box side section. Okay, following the small heatsink size, because we want to assemble the cool side at the inside the box. Okay, for the last step, we assemble all the component to the polystyrene box. Okay, we assemble this cooling element at the polystyrene box. Okay, for the final product, we can see this is the final drawing using the auto shape software. Okay, this is our final product. Okay, that's all.
Assalamualaikum, my name is Muhammad Daniel Amawi Prazlan with our matrix of AA191471. So for today, I will explain briefly about our project testing and result parts. So first, for our test, we test our functionality of our cooling box using 2 different conditions. So the first condition is we take the average temperature in a certain amount of time using an empty cooling box, and the second condition is we do the same experimental procedure, but we change it. We put 6 canned beverages in it. So we do the test for 5 times to get the most accurate temperature for each time taken. we use thermometer to take the data temperature, and lastly we plot the data in the graph, where you can see later there is two slopes that represent each of the condition. So first is the testing with the empty polysim box. We take the temperature with gap time of 15 minutes for each strip. As you can see here, the 0 to 15 minutes and 15 minutes to 30 minutes, with the gap of 15 minutes until the last minutes of 90 minutes. And you can see here, this is the first test to the fifth test, and this is the average temperature from the 0 minute to 90 minutes. So the average of ambient temperature when we do the test is 31.10 degrees Celsius. So for this graph, as you can see, when there is no load or no beverages in it, we will get 13.22 at 90 minutes. We will get 13.22 degrees Celsius at the last of 90 minutes. So let's see the next table. This is the table where we test with 6 cans of beverages. Like I said earlier, we use the same experimental procedure. We just add 6 cans of beverages in the cooling box. As you can see, this is the time taken, and this is the test where we get the average here. And as you can see here, that the data is not the cooling capabilities of the temperature drop is not higher than before, where it gets to only 18.08 degrees Celsius. So let's move on to the graph. So as you can see here, this is our graph for the cooling rate for the empty cooling box and the cooling box with 6 cans of beverages in it. As you can see, the similarities for the slope is that for the first 15 minutes it drops really high, where it can drop to 9 to 15 degrees Celsius, and for the rest of the time taken it drops slowly. This happened because of equilibrium of temperature. It is hard to reach equilibrium of the temperature when there is 6 cans of beverages in it, which explains why the cooling rate for the cooling box when there is 6 cans of beverages in it is a little bit slower. So sorry, this is the graph of the compressor based cooling rate, where I get from the research from the internet. This is from a research paper or a journal from the internet. This graph shown that the compressor base is more efficient compared to the Peltier base, because the compressor base use the refrigerant 134A gas as a main component to cooling. Yes, in terms of functionality, it is more efficient to use compressor base, but in terms of environmental friendly, it is not too efficient, because a compressor based cooling system will emit a CFC gas, a chlorofluorocarbon gas, that can endanger humans and even the environment. As you can see, for the proof of the compressor based functionality efficiency, the compressor base can drop below 55 degrees Celsius compared to Peltier base with just 18 degrees Celsius with load. As you can see here, this is the water in a refrigerator cold space. So let's move on to our next part, which is the conclusion. So for the conclusion, the first conclusion is our designated Peltier-based thermoelectric cooling box works well and has achieved all the objectives for this project. So for the first objectives, we get to design the Peltier-based thermoelectric cooling box, which for the technical drawing we use Onshape software, which is the CAD software, to draw our design. And second, we get to fabricate our project and get a physical product. And then for the second objectives, we get to test its functionality, where we do experiment into condition. As a result, we get to take data. We get to data for table, and then we get a plotted graph of two slope, and where we can compare it with a compressor based cooling system graph. And the second conclusion is it functioned well and can cool down the beverages within 30 to 60 minutes. Although it can work faster or the cooling capabilities is not as high as a compressor cooling based system, it is still worth it to use this product because this product can mobile, which it can be carried in a car where it can be used anywhere, and the power consumption is also not that high compared to a compressor based cooling system cooler. So that's all for the conclusion. Thank you.
Okay, for the recommendation, okay, we use for the first we use a bigger polystyrene box that will able to store more food or beverage that need to be kept at low temperature. Okay, it also provide greater storage space for seller, especially on the product that need to be kept in cool temperature for delivery. That is suitable for the seller that use a COD system, that is cash on delivery, to deliver the food that must be kept at a cool temperature. Okay, for the second, we use more Peltier module that connected in parallel. This can give greater cooling capabilities, which result in a shorter time taken for a product to cool down. Okay, for the third one, consider using a power from battery. Okay, the battery power source will provide mobility feature for the product, which is able to move anywhere. So for the battery, not all the battery can be used for this project. For example, we can use the deep cycle battery for this project because the deep cycle battery are usually used as a solar system. Okay, it used to keep the power from the sun and is stored in the battery. This battery can store a power in a long term. It not suitable use the battery like a car battery because it cannot keep the energy for a long time. Okay, for the reference, okay, we use two patent, one book, 4 research paper, 4 website, 2 article and 2 journal. Okay, for the total is the 15 reference that we use to finish our project. Okay, for the last one is I want to give a special thanks for Mr. Rosti bin Abdurrahman as our supervisor, and TS Mahmud Abdul Hakim bin Muhammad as CO supervisor. Okay, not forget to the Mr. Tuan Muhammad Hafiz bin Tuan Ibrahim as a panel 1, and the last one is Mrs. TS Nuraniah binti Kasim as a panel 2. Okay, that's all from me. Thank you.